Welcome to aminacademy.com. In chemistry, let us discuss about determining empirical formula of given substance. In chemistry, the empirical formula of a chemical compound is the simplest whole number ratio of atoms present in that compound. A simple example of this concept is that of empirical formula of sulfur monoxide, that is SO, means would simply be SO. That means S is one part and O is also one part. As is the empirical formula of sulfur dioxide is S2O2. Thus, sulfur monoxide and sulfur dioxide, both compounds of sulfur and oxygen, have the same empirical formula. However, their molecular formula, which express the number of atoms in each molecules of a chemical compound, are not the same. An empirical formula makes no mention of the arrangements or number of atoms. It is standard for many ionic compounds like calcium chloride, that is CaCl2, and for macromolecules such as silicon dioxide, SiO2. The molecular formula, on the other hand, shows the number of each type of atom in a molecule. The structural formula shows that arrangements of the molecules. It is also possible for different types of compounds to have equal empirical formulas. Now simplified manner, we can say that what is empirical formula? A chemical formula that shows the compound, the composition of compound in terms of the relative numbers and kinds of atoms in the simple ratio. Now we'll understand this concept by using some example problem. Here, to calculate empirical formula for percentage composition of, that is carbon 60%, hydrogen 13.4%, oxygen 26.6% by mass. Calculate the empirical formula of this substance. Now, the given composition, that is carbon percentage, equal 60%, and hydrogen percentage is 13.4%. Next, oxygen percentage is 26.6%. Now we have to calculate empirical formula of C is how much, H is how much, and O is how much. That is our aim to calculate. Here, first we will do for carbon. For carbon, that is carbon is 60% is into 100 gives 60 gram of carbon. That is 60% is converted to gram. Another for hydrogen is 13.4%, which gives into 100 equal 13.4 gram of hydrogen. Next, for oxygen is 26.6% into 100 gives gram 26.6 gram of oxygen. Now we have to calculate. Now to convert the mass of each element into the amount in moles, you must multiply with a proper conversion factor, that is here molar mass of C. Molar mass of carbon is equal 60 into 1 mole of carbon and 12 gram of carbon. That means 12 gram of carbon have 1 mole. So we are converting this as a mole, which is equal 5 mole of C. Like molar mass of hydrogen is H equal, hydrogen have 13.4 into 1 over 1.1, means for 1.01 for hydrogen, which is equal 13.3 mole of hydrogen. Then oxygen, molar mass of oxygen you are having like 26 point into 1 over 16 gram of oxygen gives 1.66 mole of oxygen. Now here, as the point of formula can be written C5, normally you can write among this calculation we have, which is C5, and hydrogen 13.3, oxygen 1.66. But you can say that subscripts are not a whole number. These are not a whole number, but we have empirical formula. They should be a whole numbers. For this, here the least number is 1.66. Therefore, we have to convert 5 mole of C over 1.66, which approximately gives 3.01. That means you are by least number LCM we are calculating. That is 1.66 is a least number here. So we have 5 mole of carbon divided by 1.66 equals mole carbon. Like hydrogen is 13.3 of mole hydrogen over 1.66 is gives approximate 8.01 mole of hydrogen, and further oxygen is 1.66 over 1.66, that is mole of hydrogen gives 1.00 mole of oxygen. This oxygen. Now we have approximate empirical formula is C3 H8 and oxygen 1. So this is the empirical formula of a given substance in percentage composition. When percentage composition is given, we are calculating empirical formula. By this way, we can calculate the empirical formula of any compound by which is given, means substance percentage is given, composition substance is given. So we have done. Please subscribe our YouTube channel.